Okay, fx equals to px cubed plus qx squared minus 4x plus 5 has a factor of x plus 1. Therefore, it means to say that f function of minus 1 equals to 0. In addition, we also know that there's a stationary point of when x is equal to negative 1/3. So differentiating for fx gives us 3p x squared plus 2qx minus 4. And we can also say that by substituting negative 1/3 into the differential, we'll get 0. So we are able to get two equations from here. First one, minus p plus q plus 4 plus 5 equals to 0. That is when we substitute negative 1 into function of x. Next, p over 3 minus 2q over 3 minus 4 equals to 0. We get this by substituting negative 1/3 into the differential of function of x. So taking 1 plus 2, the equation of 1 plus equation of 2, we get negative q minus negative 3 equals to 0. So the value of q is equal to negative 3. Putting this into the function of x, we get 2 times minus 3 plus 12 equals to 6, which is the value of p. Next, the function of x with the values of p and q will become 6x cubed minus 3x squared minus 4x plus 5. Since we already know that x plus 1 is one of the factors, we simply need to find what is the remaining quadratic function, which is 6x squared plus mx plus 5, m being the unknown. So by comparing coefficients, we see that mx squared plus 6x squared is actually equals to negative 3x squared. So m is equals to negative 9. With that, function of x is equals to x plus 1 times 6x squared minus 9x plus 5. However, 6x squared minus 9x plus 5 has no real roots. That's because when we substitute b squared minus 4ac into the root, we find that it is less than 0. The discriminant shows us it's less than 0, so it means that there's no real roots. In other words, the only real root we can find is x equals to negative 1. Therefore, there's only one real root. To find the remainder when function of x is divided by x minus 2, by using the remainder theorem, we simply just need to use function of 2. So we substitute 2 into function of x, and this is what we get. Value of the remainder is 33. Thank you.